All right, that's the 11 o'clock mark for me, so we'll get started. Thanks everybody for coming. Thanks to Moov for hosting FinTech DevCon and to all the sponsors. Just in case you think you wandered into the wrong lecture, this is using Temporal to maximize reliability, lessons from BuildCredit. So I am your speaker, Nick Palmer. I work for Array. I'm a principal engineer there and architect of our BuildCredit loan product. I thought I would go into academia, so I went and got a PhD in distributed systems, largely focused on mobile systems. Life had other plans for me, so instead I became a startup hopper and have gone from startup to startup, largely in the Bay Area, but now ended up at Array for the last 2.5 years and built out our BuildCredit loan product and otherwise do principal engineering kind of things at Array. Array provides financial identity and privacy protection tools that drive growth to financial institutions, fintechs, and digital brands who want to tap into Array's engagement in revenue-generating products to help fuel financial progress for customers. So that's what Array is all about. And so today we're going to talk about BuildCredit and how we architected and built that using Temporal. I'll go through sort of the what and why of we chose Temporal. We'll talk about some gotchas, sort of things you have to watch out for using Temporal. I'll cover some best practices that we settled on for building on top of Temporal over time and talk a little bit about how you can deploy Temporal into your products. So BuildCredit, what is BuildCredit? It's basically a white-labeled secured loan product where we originate a loan and then we store the principal in a savings account. The loan origination and servicing is handled by Array, so our partners that embed this product on their website don't have to do anything basically, including support call centers are managed by Array. It's reported to all 3 credit agencies, so the idea is that if you are unbanked or if you have messed up your credit in the past, that one of these loans will help you to raise your credit score over time. And we do a revenue share on the interest with our partner institutions. So a big part of that is loan origination. Loan origination is really complex. We have to deal with per state licensing, per state APR regulations that vary by state. We have to deal with complex APR calculations over the fees and APRs. We have to comply with Military Lending Act, as probably a bunch of you know. Have to do KYC things and do fraud detection both at loan origination and during loan processing, of course. So fairly complex piece of the puzzle is the actual loan origination itself. But even more complex is loan servicing. We deal with, of course, the loan escrow into a savings account at origination. And then we have to deal with all the payment processing that you would expect for a loan product, essentially. We have to do all the calculations for our revenue share and do payouts to our partners based on that revenue share. We get to deal with all the defaults and bankruptcies and loan surrenders that you would expect with a loan product, as well as provide an interface to our support call center for them to be able to look at loan data and make modifications to loans and trigger some of those processes. And then fraud detection is something that's ongoing all the time. And then, of course, if people pay off the loan, then we have to do the loan payout at the end of that and pay all of that off. So this is a whole lot of things that BuildCredit basically has to take care of, which means that BuildCredit has a lot of needs for reliability. This is a loan. People expect things to work reliably. They expect their payments to go to the right place. They expect their balances and principal and interest to all be calculated correctly and shown to them as they're going through the loan payback process. We wanted to build it for easy programmability, of course, because our developers have to develop all of these things. And so we wanted something that was easy for them to write software to handle all of these complex tasks. We hopefully want to build it for scalability so that we can do lots of loans and issue lots of loans, of course. So scalability is a major concern for us as we're intending to embed this in lots and lots of customer sites and issue lots and lots of loans. And that led us to sort of complex workflows that are embedded in this product as a portion of both loan origination and loan servicing. And so that was our driving force really behind choosing Temporal as a portion of our build out for this product. So what's a workflow? It's a really good question. If you're going to build choose a workflow engine, it's probably good to understand what we mean by workflow. So it's basically a series of steps that need to be completed in some process as a generalization. In our case, it's loan origination would be one workflow. You know, can we get a loan through all the various steps that we have to do pre-check for KYC, MLA, you know, API processing, all of those kinds of things, set up the loan account, wait for the user's origination fee to be taken via ACH and process that. That of course is a multi-day process, so there's, you know, a series of times that go into these workflows to get to the point where we've originated a loan and stored that balance into a savings account. And that's just one example of a complex workflow that this product needs. So what are the parts of a workflow? There's some kind of trigger which sort of causes the processing of the workflow to start. In our case, it's usually an API call. And so we built for BuildCredit an architecture where we have CRUD models that represent all the things in our data store, and there's an abstraction over that for, you know, being able to do CRUD against any of the models. And off of the endpoint for any of those models, for any CRUD action, you know, against any one of the models, you can hang a temporal workflow based on the status code of that as well, and sort of have a temporal workflow that says, for this model, if we, you know, save the loan with a 200, then go off and do these steps as a workflow, as a trigger through that system to cause a series of actions to happen. We use that also, for example, in our customer support portal, where if a CSR rep says, you know, this person has called in and said they're declaring bankruptcy, they can go find the loan in the portal and click the bankruptcy button, and that will trigger a workflow to start that processes the bankruptcy declaration. Maybe has to wait for document uploads to confirm the bankruptcy, et cetera, that runs through that workflow. Each workflow is then made up of one or more activities which are performed as a part of that processing. For loan origination, that would be calling our KYC vendor and getting back the KYC data for that user. It would be calling the MLA API would be another activity that has to happen as a step in that workflow. So just a series of activities that need to happen. Those can happen concurrently in some cases, so we could set it up so that we do the KYC check and the MLA check at the same time, or they could happen one after the other, depending on how you design that workflow. And then, of course, there's results and side effects of that processing of the workflow, of those activities. The result is sort of the resulting status. Was the loan approved? Was the loan denied as part of that process? Or side effects like, you know, we have opened a bank account would be a great example of a side effect of processing some particular thing. So for us in particular, we wanted reliability as a portion of that process. We want things to just work. Customers expect everything to process reliably and to work reliably. That's challenging, especially in distributed systems that we all are building these days. We have multiple vendors that we have to rely on. So there's lots of sources of error in any of these processes that we've abstracted as a workflow. So it could be that HTTP calls to partner APIs fail. This is sort of, you know, they're having an outage, and so we can't talk to them right now. We have to wait for them to come back up to take that action in their system. It could be database availability. You know, somebody's applying for a loan in the middle of the night, and we're in a maintenance window and doing some maintenance on our database, and the database is down. We need the process to, when the database is back up, come back reliably and do the things that it needs to do against the database at that point. It could be hardware failure. You know, some node in our K8's infrastructure goes down, and the process that was processing that particular thing was in the middle of doing something, and boom, state is completely lost. The process has completely died. I was at a talk earlier that was talking about deploying Chaos Monkey from Netflix into your infrastructure to just, you know, take out a unit of processing at some point, and being able to handle that reliably is important for overall reliability of the system. And then, of course, there's software bugs. We try to test our code the best we can, of course, but there's always cases where developers make mistakes, where the unit tests didn't catch something, where you discover some kind of bug in the system, and we'd like the system to be easy to recover from some kind of software programming mistake, have a way to fix that bug and have the problems that are occurring in that bug, when the bug is fixed, that the workflow can continue on and that process can continue reliably. So that was a major concern for us in terms of building this product to be reliable for customers. How do you deal with mistakes? Well, oops, that didn't work, we're going to try it again. And retries are a very common pattern for dealing with these things. So if some HTTP call to a partner fails, we retry that call again, preferably over some kind of exponential backoff so we don't kill them if they're having an outage and take down their system. And we'd like to be able to tune that, obviously, for each of our external partners in an appropriate way for that particular partner based on the load that they can handle and what we see happening in that. Same for database calls. If our database is down, we need to go run that transaction again, execute again when the database comes up. We don't want to spam the database engine with tons of attempts to connect, so we'd like it to have some kind of exponential backoff against the database retry. In terms of hardware failures, we'd like to be able to resume that workflow and go, okay, we're going to process this workflow again, starting at the place that it failed the last time to deal with that hardware failure. And software bugs, this is great as well. We'd love to be able to fix a bug, deploy the fix, and have the workflow pick up where it was and process that buggy bit again from where it is. Of course, that depends a little bit on what kind of bug it was, but ideally, if there's an activity that's failing because we didn't account for something, somebody had a null pointer error somewhere in that, and it's just crashing on a regular basis, throws a panic and says, I can't do anything because this field that I'm counting on is null, then we can fix that and redeploy, and the workflow will just pick up that new software and run with it, and away we go with a properly running workflow. So retries is basically the technique that everybody uses to deal with all of these kinds of failures. Just try again. So the big idea behind sort of going with some kind of workflow and how does the workflow work, what's the big idea that's driving this workflow engine? It's pretty simple when it comes down to it. You save the input and output of each step in some kind of durable storage. So I have some kind of inputs to my activity that says, call this API, here's the input parameters, or here's where you go and get the input parameters out of the database, go make this API call and give me back the result of that API call. And keep that in some kind of durable storage so that we can, well, that has a bunch of advantages. We can go look at what happened and we can retry that step over and over again until it succeeds properly. And then the idea is to run coordination code to create a job for each step. So that is the workflow essentially that creates a job in our job queue inside Temporal for each step in that workflow. And then we can rerun failed jobs until they succeed or they eventually time out. Of course, we are going to have cases where a partner is down for 6 days and we don't want to keep trying forever. We need that to error out and go deal with that in a different way. So handling timeouts or those sorts of failures is an appropriate part of designing for, we don't want to have infinite retries on things forever. And then, of course, we can rerun coordination code until all the steps are complete. And that's basically the idea is I can program my workflow, and if some part of it fails, then I can come back and I can rerun that workflow again and take out of history, take out of that durable storage anything that's already been executed, and then rerun until I get to a step that hasn't completed successfully and go from there. So when it's all over, then I have some kind of result. So loan approved is a great result, loan denied, another kind of result, and we can return that result to the caller and or bookkeep that was the result of this particular workflow. And so that leads us to the concept of durable workflows, where the workflow is essentially stored somewhere in storage, that history is durable. This gives us a bunch of advantages that we really liked for this build in particular. It's a very simple programming model because the developers largely don't have to think about how do I retry something. They just abstract things into an activity. Here's the activity to go call some partner API, and they don't have to worry about how to retry that, and we can tune retries as a separate concern. So it simplifies failure handling because essentially every activity can return what happened for that activity. We called this API, we got a 500. I can return that back up to the workflow. The workflow goes, oh, this got a 500. Well, I'm configured to retry that particular activity until I get a 200 or it times out. So I'm going to wait a little bit, whatever that activity has been configured in terms of its retry and then I'm going to go and retry that thing again. So it makes that a separate concern, which is extremely nice. And then this is a scalable distributed system. So the idea is that if we need to scale up, we need to be able to do more work, we just attach more workers to the job queue and it picks up more activities. We can run more things concurrently up to whatever the maximum number that the distributed system can handle. So we chose Temporal because we went and looked at a bunch of different workflow engines and we like this one. They are a vendor here. I'm not associated with them at all, but we do really like their product and are one of their customers. We like it because it's fault tolerant. Because of that durability and using a durable store to store workflow state, it handles both failures of workers, failures of issues in Temporal itself. You can shut down the Temporal cluster and bring it back up again, and everything will pick up and the system will begin to operate again very nominally. So it has built-in visibility. This is something that I think is really important and is something that a lot of people miss as they're building systems. Visibility and observability is very important for understanding what the system is doing, especially in distributed systems where there are emergent behaviors that you didn't expect. You need a way to be able to go and introspect what happened. And the fact that you're using this durable workflow engine and that there's some UI that allows you to go and look at what are all the history steps that happened in this workflow. Are there maybe other workflows that were running concurrently? Can I go look at those and see what steps they took? What are the inputs and outputs to each of these activities? That gives a visibility into how the system is operating. And then of course there's always metrics around Temporal itself in terms of how long is it taking to pick up jobs? How long are jobs sitting in the queue? Do I have enough workers attached to it? Do I need to scale up my workers and set up horizontal auto-scaling on my workers based on what Temporal is telling us about how it's processing jobs? All of that kind of visibility is already built into Temporal and gives you a great way to operate that product and to figure out what's going on, what are the emergent behaviors of the distributed system that you built. And of course, Temporal is great because it has multiple language bindings. We build our backends in Golang, so that was certainly one consideration. There are other workflow engines that do have multiple language bindings, but for Temporal, it's a great feature. And we loved that it's open source. I go and read the Temporal internal code or used to, on a fairly regular basis as part of looking at how does the system operate, and that visibility into how it actually works is fantastic. And then you can deploy it either as a self-hosted or a cloud SaaS. We started with self-hosted, and I'll talk more about that later, and then migrated to the cloud SaaS solution. So what is Temporal? It has a few primary components. There's the Temporal server, of course, that's the primary workhorse of Temporal that's persisting job state and coordinating the workers. There's a Temporal client SDKs, of course, in every language. That's a portion of the system as well to be able to talk to that Temporal API that the Temporal server is offering. There's a Temporal web UI, that's that visibility component, and it's a separate component that deploys in a separate container. And then there's persistence, which you get to bring your own to Temporal. Do you want to be on top of Cassandra? Do you want to be on top of SQL? We deployed originally into our environment on top of Postgres. For the cloud model, they use Cassandra in the cloud. So concepts that are important for understanding Temporal workflows, we talked a bunch about those. That's a key concept to be able to build on top of this workflow engine. Activities, of course, are a primary concept in Temporal, being able to decompose the process that you need to run into individual activities. And there is a little bit of an art to how do you decompose things into activities that I'll talk about a little bit more in terms of largely that's around controlling concurrency. Temporal is a concurrent system, and so and it's not a silver bullet for concurrency, so you do need to think through concurrency issues, and I'll talk about that a little bit more in a bit. Of course, Temporal has task queues. These are queues where workers will pick up various work, and you can separate out various kinds of jobs into different task queues if you want to. If you're building a system that maybe needs GPUs for running certain AI tasks, then you could separate those into separate task queues so that the workers that are running on machines that have a GPU pick up different sets of tasks than workers that are running some other job that doesn't need specialized hardware or doesn't need something in particular. And then there are signals in Temporal. I think of these as sort of pause points where you can stop and wait for something external in Temporal. It's just a way of pausing execution and then allowing some other portion of the system to signal to the workflow that it's okay to proceed on. And history, of course. That's sort of the central concept of this durable workflows model, is that saving of history in some kind of durable storage. So workflows are basically one or more activities. You can also fire off child workflow calls. So we have some processes, for example, nightly processing is a workflow that goes and looks at what are all the things that I need to do on a nightly basis. I want to go and recompute everybody's earned interest, or I want to go and do the bit of processing on a regular basis, and we basically look at all the records that we can and then spin off a child workflow that goes through and processes each of those records with some kind of child workflow. Workflows can take parameters, of course. That's sort of the input to that particular thing. In the case of the model for BuildCredit, it's essentially the ID of the model that was the result of that CRUD operation. So if I do a delete on a model, I'll get that model ID. If I do a create of a model, I get the model ID, and then the workflow can go and pull that out of the database. They must return an error. It could be that there's no error, and that's a valid thing, but it must return some kind of error so that if there is a problem with that workflow, that's surfaced up to the UI layer. It can return an additional value, and that can be very useful for visibility for sure, and give you some kind of understanding of what happened in that workflow at the end, what was the final decision. And they can contain branching logic. So you can do things where you're saying, if this is the case of this activity, then go do this thing. If they were KYC denied, then return that their loan is denied. If they KYC approved, then go on to the next MLA check. That branching logic is allowed to be part of a workflow. But they must be deterministic, so you can't have random things in that workflow, because the model is, we're going to rerun steps that we took already and give the answer back from history to resume that workflow, so you can't have randomness in there, or the re-execution of that workflow won't take the same steps. So that also means that they can't make any blocking calls. The actual workflow processor will error out at you if you're making some kind of blocking I/O within that workflow. And that's partly as well because it wants that job to run quickly to spin off new activity jobs. But the workflows themselves can't block. If you want to block a workflow, then you use a signal, and that's the blocking mechanism, because it allows that job to terminate effectively within the workers, and Temporal takes care of picking that workflow up again and rescheduling that workflow to run once the signal has been sensed into history, essentially. So this is an example workflow. I've tried to simplify it down to as simple as I can here. This is in Golang, because we program largely in Golang. The key piece here is up at the top, there's two activity options where I'm setting different aspects of timeouts for these two activities. On the top one, I'm saying, we want this operation, we expect it to be finished in 10 seconds. So from the time that it starts to the time that that activity is done, it shouldn't take more than 10 seconds. And the next one has a timeout of 10 minutes. From the time that that activity starts until it should be done, shouldn't be more than 10 minutes. And the Temporal engine has a number of different parameters that you can configure in terms of the options that you want on the activity. How many times should you retry? What should be the exponential back off? What kind of time do you want in between? All of those things are things that you can set on your activity options to tune that activity. The nice thing about that is you can sort of set default reasonable options. I expect API calls to finish in 10 seconds for every API call that we make to this partner. If it takes more than 10 seconds, they're probably having an outage, and you might as well just kill the activity and we'll retry it again later on a different schedule. And then essentially all you're doing is well, you're grabbing a logger. This is kind of an interesting feature of Temporal because, of course, logging steps within a workflow itself, when you rerun that workflow, they're going to log again. So the workflow logger essentially is storing that this was logged or not as a portion of that history, so you don't get log messages for workflows that are just being resumed as they go through. So that's why that exists there. And so then basically you're just saying, I want to go execute this activity. When you call execute activity, it returns a future. In this case, I'm immediately getting the result of that future, so that get call is going to block within this workflow, and Temporal is going to let this workflow stop, the execution of the workflow job, until that activity has persisted into durable storage, and then Temporal will reschedule the workflow and it'll run until it hits that get call and return the result of that get immediately. And here I'm not pulling any result parameter here, just if it errors or not, so that's why there's that nil on the get there. And then there's a second activity as a portion of this one with the different timeout, and we're essentially calling a different activity to say that's just scheduling that activity job into Temporal and getting the result of that. And so then going through the series of steps that are this thing and returning a status complete at the end that this particular activity is finished, or this particular workflow is finished. To execute a workflow then in code, we essentially say like we're going to process some expense here, so this would be an expense example. We assign a UUID for that expense that would probably come from your database backend, and we set up the workflow options to say, here's the ID for this workflow, we're going to go process expense number, whatever that ID is, and we're going to put it on the expense task queue. Putting it on that task queue means workers that have registered to be able to process expense activities will listen on that queue and be able to pick them up, so that allows you to segment your workers into various pools of workers that are executing different piles of code. And then you just go execute the workflow. So activities are basically one or more actions to be taken. They can take arguments, they must return an error, and they may return an additional value. They can contain blocking calls. This is the whole point of activities. They will consume one of your workers as they're sitting blocking on some API call or blocking on the database. They must be idempotent, and this of course is a big topic in fintech, of course, because if we're moving money around between accounts, we ideally don't want that to be done twice if it needs to be. So hopefully your vendors and your APIs that you're working with support some kind of idempotency key. And they can return pending retriable or non-retriable errors. If they return a pending error, it sort of pauses the workflow and the activity can be resumed later. Retriable errors will be retried, but you can also mark things as non-retriable and that will kill the workflow. The activity will come back and the else block that's handling the error from that activity will fire. So this is an example activity that would create an expense. Nothing really fancy here, just calling an HTTP call and returning a particular result. This is the simple programming model, right? My developers can decompose a simple task like this and say, here's the one task we're going to run as this activity, and that sort of gives you a kind of repo model of activities that my developers can then reach into and recompose. So we ended up with many activities that are, go persist this into the database or go load this from the database as sort of standard activities. So then I mentioned task queues. These are created dynamically by Temporal based on you saying there's some particular task queue. There are activity and workflow task queues. Those can be separated in terms of workers if you want to and have a separate pool of workers processing activities from workflows. Then workers basically poll a task queue for jobs. That enables you to route things, as I've been saying, to different places. You can shove your work into this specialized worker queue, pile of workers or not. And tasks can be prioritized. So you can't say, hey, this is a super important job, we want to get it done quickly, and this cron job that we're running in the background, we run with lower priority so that high priority jobs that maybe have a UI user waiting on some kind of polling interval can be pushed up the queue. Signals are that coordination mechanism. They enable coordination of workflow execution. Workflows can pause, waiting for some particular signal. In our case, maybe waiting for a webhook back from a particular vendor. We make a call to create a payment, and they webhook us back when that payment settles. And they're similar to activities in that returning a pending error, sort of saying this operation is going to pause the workflow until something else comes in and signals. So this is an example of a signal where essentially we're saying, until we get this invoice, we're not going to do anything. We're going to add a receive channel essentially to receive that signal, and then we're just going to select and wait for that signal to come in. Elsewhere in the code in the HTTP handler, we can then send that signal and say, we're going to confirm that this invoice, we received it, and that will cause the workflow to continue on after that select call. The next concept I've been talking a lot about, this should seem very familiar to you by now, is this idea of temporal history. There's some event, and Temporal keeps, the time that it started and the inputs to that and any result, and can therefore execute the workflow code over and over again out of that history. So it's the recorded input to and result of each activity. We use that to replay and resume a workflow, and that history can be introspected. That provides visibility for that operationalization of the product. Resumption is then done by calling that workflow code again. So from the developer's perspective, there's no real difference to writing the workflow once and having it execute multiple times. The results of completed activities are returned from history as it replays that code, essentially. So gotchas. What are the gotchas in the system? What are the things that you guys are going to stumble on that I'm here to teach you what we stumbled on, essentially, as we went through. So deterministic workflows, you can definitely stumble on that. If you're calling a clock to get some kind of time and calculating a time difference, not going to work. You need to call the workflow's idea of now so that you get the same time if you rerun that workflow. Random number generator is bad in a workflow. Don't do that. Idempotent activities is definitely a gotcha. If you're talking to APIs that don't have an idempotency key, then you got to figure out a way that you can rerun that activity over and over again, because maybe they timed out and you set the timeout as 10 seconds, but they took 15 seconds and they actually did take that action. So maybe that activity has to go in query. Is this done first before it goes on? And both of those steps need to be in that activity to make sure that that activity itself is idempotent. Versioning, Temporal doesn't handle versioning of your code for you, so I'll have some advice on how to do versioning, but you get to version your workflows if the logic of a workflow changes. There may be workflows that are currently running, and if you don't allow those with workers with the old code to finish, then you're going to run into trouble because the activities maybe don't line up anymore. You inserted this activity up here, but there's no history result in that, so there are some versioning complexity that developers do have to be aware of. And concurrency. Temporal is not a concurrency magic solution to concurrency bugs and concurrency issues in distributed systems. That's definitely a gotcha. In terms of determinism, cannot use random numbers, cannot use direct access to time, and can't do any I/O. So that's how workflows stay deterministic. In terms of idempotent activities, using database transactions and checking preconditions is critical. So check and make sure that the things that I expected to be there before we began this are still there in the database, and I should actually run this activity. API calls may need idempotency keys. In terms of versioning, workflows and activities are versioned by name. So if you want to have a new version of a workflow, you can handle that by changing the name of it to _v1 and calling that function from your code that's kicking off a workflow. If you leave the old version of the workflow registered, then workflows that are currently running can use that old version of the workflow still. And execute the old version of that code if you need to make changes that won't work against running history. Argument counts to workflows and activities cannot change. Not particularly surprising. What Temporal does under the hood is basically persist a JSON blob or whatever serialization you register into the database and then unpersist it back into your model. So if you change the number of things, that can break. So you don't want to change that unless you're changing the version. And redeployments can happen with pending workflows. So you might redeploy your code base and there's a bunch of workflows that are in progress, and you need to be aware that can happen and design for that. In terms of concurrency, Temporal is a concurrent system. Your workers run in parallel with up to however many workers you've scheduled to run, so jobs are running concurrently. You need to use database transactions in activities and check those preconditions to deal with that concurrency. Workflow IDs can be used to control workflow concurrency. I'll talk a little bit more about that in a minute. And then you need to consider potential concurrency cases in your activities. If two activities are both operating against some particular model, you need to think about, how do I keep these things from happening concurrently? Am I using transactions in my activity against my ACID compliant data store? Or how am I dealing with the concurrency issues of multiple things running together? So best practices, use a single input parameter object. This allows you to not have to version your workflows as often if you use that schema evolution against the JSON binding, essentially, to say, like, okay, we got this. I can handle in my code the fact that this parameter within our argument is not there. I want to add a new argument. I can handle that as a default, and the number of arguments to my workflow don't change. I can deal with that within the same workflow and not have to do a new version name of that particular workflow. You should return a status object from all workflows. This is about visibility, really. That makes it so that when you're looking at the workflow in the UI, you can see what was the result of this workflow immediately, and that can help your developers as they're operating the product. We didn't do that at first, and we're dissatisfied with the visibility there, so that's a great best practice. You need to design with the scale limits in mind. Temporal is very scalable. It does have some limits in terms of what it can actually do. And you should use workflow IDs to control concurrency. That ID is important. Temporal will not run duplicate workflows. So that single input parameter avoids that workflow versioning. It pushes schema evolution into the workflow using that JSON binding. That status object is that improved visibility. The scale limits, you can only use 100 namespaces, so think about that as you're sort of dividing your tasks up into different namespaces. You can only have 5,000 workers polling for jobs, and that sort of is the maximum number of workers just in terms of communication to that temporal server and pulling information out of that durable store, so that sort of gets you to a certain scale. We haven't run up to this yet in our system, but you could deploy multiple temporal clusters then if that becomes your problem. Event history has a maximum size of 4 megabytes, so generally speaking, you want to persist small IDs as arguments to your activities and your workflows. Don't put your large objects, don't try to stick some document into the temporal history table. Those should be small, ideally. Also for that I/O in and out of the server to your workers. And maximum payload size is 2 megabytes, so you can't stick more than 2 megabytes into some particular payload to an activity. You can have a maximum of 2,000 incomplete activities per workflow. So like if you have some cron that's going to touch 10,000 accounts, you cannot load all 10,000 of them and run all those activities in parallel. That's a bad design on top of temporal. And you can have a max of 10,000 signals per workflow. So you can't infinitely pause a workflow. There is a limit there in terms of how they can select that out of history. And then there are history limits, 10,240 events, in a history and 10 megabytes of total history store for any particular workflow. Again, if you're using small IDs as your input parameters, you're very unlikely to hit 10 megabytes of UUIDs. That workflow IDs to control concurrency, like I said, Temporal will only run one workflow with a given ID at a time, so you can use your model IDs to sort of control the number of concurrent tasks that are running against any particular model, so that you're not trying to interleave database transactions at the same time, or you're not trying to do a loan approval for some particular customer twice at the same time if your front-end developers didn't gray out the button and are making 2 API calls to apply for a loan twice. Ideally, you don't want to do that twice. That can be used to prevent potential concurrency bugs. It doesn't solve all your potential concurrency bugs, but it does eliminate some classes of them. So we use model IDs and those workflow IDs to prevent those concurrent model changes. And that brings us to the deployment of Temporal. Of course, if you're going to pick this product, you get to stick it in your infrastructure somewhere. You can go with the self-hosted model, or you can go with the cloud SaaS model. In terms of self-hosted, you get deployable Docker containers from Temporal with whatever version of the Temporal engine you're running, and can deploy that into whatever your favorite container system is. You can choose your persistence engine and sort of bring your own persistence engine. Are you building on top of Cassandra because you have that in your infrastructure and your SREs know how to deploy Cassandra and manage a Cassandra cluster, or are you going to go on top of PostgreSQL and sort of deal with the scaling issues on top of PostgreSQL as Temporal itself scales up? And with that, of course, you have all that self-managed overhead in terms of SRE time to manage the cluster, to deal with versioning of that cluster. Oh, Temporal did a new version, we need to release that cluster, and spin up a new cluster. How are we going to manage that aspect of it? So there is a certain self-management overhead to going with this choice. Temporal does offer a cloud SaaS product, and so that's how they're making their money, of course, to continue to fund development on it. You're charged per activity or per scheduled workflow, essentially. So that does impact some in terms of if you're going to cloud SaaS. We did go back and recompose some of our things to reduce the total number of activities in some of our very high-use workflows, to do more things in one activity, to reduce the spends to the cloud SaaS, essentially, because this is currently their billing model. It does have a better web UI than the default one that they ship from open source, so we do enjoy their Cloud SaaS web UI and feel that that's a differentiator between the two solutions, although the web UI that comes with the open source product is also quite reasonable. And our analysis at full load of SCO or SRE cost was that total cost of ownership is lower on the Cloud SaaS, but please run your own analysis if you're considering deploying Temporal and look at what your SRE costs are and think through sort of what's our cost to own and operate this versus having it in the cloud. Of course, this being fintech, there may be compliance issues, and so your InfoSec department is going to want to check their SOC 2 and do all of that kind of fun stuff as you're integrating into their cloud offering. So, but it's nice that you sort of have both choices. You're not limited in terms of that. In terms of doing that migration or doing updates from one version to another, if you're updating the version of Temporal, what you can do is connect processes to both Temporal clusters. So we taught our system essentially to say, here are 2 Temporal clusters, and I know how to open client connections to both of those and to schedule worker pools on both clusters. So our workers would, we'd have a set of workers that are listening on one cluster, a set of workers that are listening for work on the other cluster. And then we would only schedule new workflows on whatever the target new cluster is going to be. That way all new work is going into that cluster and being picked up by the new workers. And then as you would expect, you wait for all workflows on the old cluster to complete. Ideally, they're using the same durable storage engine behind the scenes, and so that becomes not an issue in terms of the version upgrade of Temporal itself, or moving to Cloud SaaS. You're going to end up with 2 web UIs for things that ran in the past versus things that are there, or vice versa. And then you basically, once all the workflows are completed, you can retire that old cluster. And so you can do these upgrades with 0 downtime, and this is sort of the path to doing that. Or if you want to migrate from cloud back to on-prem, or from on-prem back to cloud, this is the path that we took to go from on-prem to cloud with 0 downtime, essentially. And so there you go. Thank you very much for coming to this talk. Are there any questions? Can I answer anything for anybody?
Does it have the concept to do things like A/B testing, where if you want to send, say, 10% of your traffic down one flow, just so that you can do like side-by-side comparisons? Is there an easy way to do that?
That's a great question. So the question is there a way to do A/B testing? Does it have that built in? It's not built in directly into Temporal. What you can do to do that essentially is integrate whatever your A/B test framework is. We use LaunchDarkly to sort of set up those flags, and you set up the fetching of that feature flag as an activity, and the return value from whether or not it should go down this code path or that code path essentially comes back from that activity. That means when the workflow replays, it'll be replaying in that I want to run this mode, I want to run that mode. And one way that you can structure that is to build out child workflows as, this is the workflow to kick off if you get this thing, this is the workflow to kick off if you're on the other side of that A/B test. And then you can look at those as separate sort of child workflows. You can, in the web UI, you can then search for those child workflows in particular if you want to look at how did the results of this particular, the A side go versus now I'm going to search for the B side, because they're separate child workflows that will show up separately in that history. It's a great question. Anybody else?
You touched on it a little bit with the versioning, but are there any like catches or things to consider when adding steps to the middle of a workflow, like kind of changing that durable step that impacts kind of the future steps online?
That's a great question. So the ask was about versioning. Are there issues with selecting steps, essentially with changing the steps in a workflow? If you're changing the order of activities, or you're changing the number of activities that are running in there, you have to think about it in terms of that history model. Is this change going to impact it for running workflows? In general, yes, you need to then version your workflow. So it's good to think when you're building out your workflow, what are the activities that this is going to need to do, and try not to change those, because that is a good reason to version your workflow in terms of, but you could do it where, I'm going to insert a step at the end. That's not something that you would have to version, because every workflow that's run, if it's in process right now and it's on that step, when that comes back, it's going to run the next step. So it's a little bit thinking in terms of that history of what it is. You could use other mechanisms to do that as well, but it's generally best to just version the workflow at that point and update the name. It's a great question, though. There was another question over here. Go ahead.
How do you
How do we think about reliability in terms of Temporal itself? It's a great question. For us, we're very happy with the reliability that we've seen from the SaaS platform, and we were very happy with what we saw with it on-prem, but it is certainly one of the distributed components that's there. And of course, there's a potential as a single system to have a failure within Temporal, that the Temporal server crashes and has some kind of problem there. The great thing is that you can use that upgrade model to potentially have more than one Temporal cluster running at the same time. If they're using the same persistent store, then you're back to the classic problem of my data store has to stay up, but I can have multiple Temporal servers running. There's no problem with running multiple Temporal servers against that data store, so you can get more reliability that way and then schedule workers that are going against this version or against that version, or selecting out of both task queues in terms of that to eliminate that as a single point of failure. So far, we've been running it for about 2.5 years now, and we've never had Temporal be the reason that something was going wrong. It's almost always partner API is down, our database is in maintenance, or somebody wrote a bug. So we're very happy with the performance of Temporal so far, but it's a great question for sure.
What were the biggest reasons that drove you to go from on-prem to the cloud?
There were two things there, really. We wanted features that were in a newer version, and we looked at the cost of sort of doing that transition of spinning up a new Temporal cluster in terms of SRE time versus moving to the cloud where they sort of handle those things for you on a running basis. And we felt that, and we were also at a point where we needed to scale up our Postgres instance, and we sort of looked at the cost of doing both of those things, ran an analysis at that point in time and said, let's go to the SaaS model where our SRE team then doesn't have to worry about this. But it's really just a question of, do you have an SRE function that can manage this on-prem, and that's the way you'd like to deploy it, and they're happy doing that? Or do you prefer to have the lower SRE cost and go to the SaaS model, sort of the classic, buy or build kind of problems that you have. It worked great in both situations for us. We were very happy with it in both situations. It was more a question of our SREs didn't want to prioritize that up above other SRE tasks that they had on their plate, and so we felt that, in order to move forward, it was better to move to the cloud model, just to get that regular cadence of version updates and management of the data store that we didn't feel like our SRE team was wanting to handle that. It's really a question of, we're a scrappy startup still, so that was our primary reason for migrating. Any other questions?
Touch briefly on the third-party API you're integrating with that doesn't support idempotency, other techniques. I mean, do you have any that have been successful for you? It's certainly something.
Well, for some of the APIs we integrate with, they don't have an idempotency key, but we're basically just fetching information out of them. So like our MLA check, that API doesn't have idempotency on it, but a get of the MLA status of someone is the same as the next get of the MLA status of someone. In terms of rights, fortunately, all the things that we have to integrate against that are right-based APIs have idempotency keys. So certainly the banking applications that, the banking operating system that we integrate with does. Our KYC vendor does not, but a KYC of somebody twice, you get the same result hopefully from that vendor, and it doesn't matter that we've KYC'd them twice, apart from we're going to end up paying for it twice if they book kept both of those operations. So otherwise, you're left with, let me do the classic thing of, use that ID to control concurrency. Maybe you're using a workflow ID that's associated with that model, and you're making a get call ahead in the activity, making a get call to pull current state. We do that in transactions as well to sort of verify, hey, I have a state that says I should run this activity at this point within some of our activities to control the potential for a concurrency bug. We're going to run this activity. We assume that the loan is currently unfunded as we're going to run this, and let me pull the loan in a transaction and say, yes, this loan is unfunded, make modifications to the loan and persist that back out, and that check at the beginning makes sure that if there's another activity that's trying to run a transaction against that loan, that in fact it was in the unfunded state when we went, and that's just sort of classic using ACID compliance to control that concurrency. Any other questions? All right, thank you so much for coming, and thanks for attending FinTech DevCon, and I was told by my people to say at the end, we are hiring. So if you'd like to come work with Temporal, then get in touch. Thank you so much.